Okay, in this video, I'm just going to go through two of the more difficult titration calculation questions. The first one is about identifying an unknown salt, and the other is using the back titration technique. So this question, I think, came up like 2 years ago. There's other parts of the question, but I'm just going to focus on the difficult part, which is identifying compound B. So you're told compound B is an iodate salt of a group 1 metal. The iodate ion is IO3-, but there must be a group 1 metal to go alongside it. And they carry out a titration to work this out. They're taking 1.55 grams of B, dissolving it up to 250. They're then pipetting 25 centimetres cubed of B into a conical flask. So you're using the solution in your titration, followed by 10 centimetres cubed of sulfuric acid and an excess of Ki, and then the iodate ions are reduced. So by adding, you've got an equation for it here, by adding the acid and by adding the potassium iodide, they react with the iodate ions and they reduce them to I2. And then the resulting mixture is then what is titrated against sodium thiosulfate. And you can see here from the equation that it's specifically the iodine that is going to react with the sodium thiosulfate. So like with all of these questions, you're given lots and lots of information, but we're ultimately going to start with the titration. And this equation here represents a titration, and I can see that it's the iodine, the I2, that is being titrated against the sodium thiosulfate S2O3 2-. So going back through the question, I need to pick out, I should have 2 volumes and 1 concentration, and then I'm trying to find that second concentration. So I'm told that I have got 25 centimetres cubed of that solution B. So I'm going to write that down under my I2 because that's what ultimately led to this I2. So I'm going to write down my 25, dividing by 1,000 to get it into decimeters cubed. The amount of sodium thiosulfate required, you'd have to use the titration reading. So this is in your burette, so you'd have to use the titration readings. You'll see when I fill this table in, I've got everything recorded to 2 decimal places, so even when it ends in 0. And then using these results, I'm going to get my 2 concordant results, which are 2 and 3, and I'm going to work out the mean, which is 23.80. So I'm going to fill that in there, 0.0238. So as I said, there was lots of other parts to this question. I'm just going to focus on the difficult part. You are also told the concentration of the iodate, 0.150. So 0.150. And using this equation here, I can work out the ratio, and it gives me a 1:2 ratio between the iodine and the sodium thiosulfate. So I'm just going to work this out. All right, so I've filled in my table. So I've worked out the number of moles by timesing these 2 numbers together, and then I've used my ratio to work out the number of moles of I2. So at this point, I've just used this equation here to work out the number of moles of I2 I had. But this is where it gets a little bit tricky, all right? If we read the question, we're not being asked about I2, we're being asked about the iodate salt, and iodine is not the same as this iodate salt. So what we'll need to do, now that we know the moles of I2, we'll need to use this equation to work out the number of moles of the iodate ion that we would have originally started with, because that's ultimately what we're being asked about. So taken from my titration table, the information that I get is this, all right? This is the number of moles of I2 that I've gotten 25 centimetres cubed. But I don't care about the I2, I need to get back to the iodate. So using this equation here, I can see the ratio between the iodate ion and I2 is 1:3. So I'm going to write that down for myself. The iodate ion, IO3-, and I2, they're in a ratio of 1:3. Okay, so if I had 1 mole, I would be producing 3 moles. But we can see with the iodine that the number of moles we ended up producing was 1.785 by 10 to the -3. So I'm going to need to divide this number by 3 to work out the number of moles of the iodate, 5.95 by 10 to the -4. So if I have that number of iodine moles in 25 centimetres cubed, then I'd have that number of iodate moles in 25 centimetres cubed. But then again, going back to the question, you'll see that you're making it up in a 250 centimetres cubed flask. So what I'm going to need to do now is I'm going to take the number of moles and I'm going to need to times it by 10. I need to scale up by 10 so I know the number of moles I have in 250 centimeters cubed. So that's the number of moles of my iodate. Now I'm not talking about iodine anymore, of iodate in 250 centimeters cubed. Going back to the question, I can see that I've got mass of B. So I've got mass, I've got moles, I can use this information to find formula mass. So it's going to be my mass, 1.55 grams, divided by my moles, 5.95 by 10 to the minus 3. Divided by 5.95 to the minus 3. And that equals 260.50. All right, so that is the formula mass of the entire iodate. Now we are told, the formula of our salt is just a group 1 metal alongside IO3 minus. So what I can do now, if I know that the formula mass, let's call the unknown group 1 metal X, the formula mass of the entire thing is 260.50. If I work out the formula mass of the iodate ion, that works out as being 174.9. And then I can work out the formula mass of X by just subtracting 260, subtracting 174, and I get 85.1. All I need to do then is go to my periodic table and find the group 1 metal with an atomic mass of 85, and the answer is rubidium. So like we've seen before, if you're trying to work out an unknown, ultimately you're going to try and find a formula mass. I think the tricky thing here is the ratio. Common mistake would be using the moles of iodine and carrying that forward, but it's not iodine that we care about, it's the iodate. So you need to use the first equation that they give you to work out the number of moles of iodate. You then need to remember to scale up to 250, and once you've done that, the rest of the question should be a little bit more straightforward. All right, so the next question I'm going to go through is the back titration. The calculation itself for the back titration came up for 6 marks, but then there were other parts of this question as well. So it's quite a long question, all on titrations. And the question does give you some guidance. It kind of explains how the back titration technique works. So you're trying to analyze this metal, and they react it with an excess of acid, and the resulting solution is then titrated to see how much is left over. So just like what we've seen before. So if you haven't watched the video on back titrations, please do so. But you do the titration to find out how much acid is left over. You'll be using this information later on in the question to work out how much acid you started with, but we're going to initially look at the titration information to see how much acid is left over. So with all that acid that was left over, you are going to titrate it against sodium hydroxide. And they give you the equation for it just down here. So you've got sodium hydroxide and the excess HCl being titrated against each other. So initially, the calculation is just going to start with your typical titration table. You're given the volumes down here. You're going to have to work out the different titers. So I've done that again, recording my answers to 2 decimal places, and then using my 1 and 3, my concordant results, I work out that my mean is 27.25, and that refers to the sodium hydroxide. So I'm going to fill that into my table, 27.25, having put it into decimeters cubed. I'm told the concentration of my sodium hydroxide is 0.320, and I'm told the volume up here is 0.025. Using my equation, I can see that the ratio between these two is 1:1. So I can use this information and I can work out the number of moles of HCl that I've got left over. Okay, so I filled all that information into my table, and I have worked out that the number of moles of HCl I have in 25 centimeters cubed is 8.72 by 10 to the minus 3. If we go back and look at the question though, you'll see that the solution, the one containing the HCl, was made up to 250 centimeters cubed. So I'm going to need to work out how many moles I've got in 250. So I scroll across here. From my table, I know I've got that many in 25. I times by 10 to work out the number of moles I've got in 250. So that tells me the number of HCl moles that I have left over after the reaction with the acid. I can now work out the number of moles of HCl that I started with, using the information given to me in the question. So the numbers I highlighted up here, I'm told the volume and the concentration of the HCl that I started with. I can then work out the moles of HCl that I started with. So to do that, I'm going to convert centimetres cubed to decimeters cubed so that the units of volume match the units of concentration. So I end up with 0.1 as my volume times 2.10 as my concentration. And this number here then represents the number of moles of HCl that I started with. So I'm going to fill that here into the little table that I've made. Number of moles of HCl that I started with, 0.21. So I know the number of moles that was left after the reaction. I know the number of moles that I started with. So by just subtracting one from the other, I'm going to work out the number of moles of HCl that actually reacted with my metal. So that's the number of moles that reacted with my metal. If I know the number of moles that reacted with the metal, I can use the equation between the acid and the metal to work out the number of moles of metal I must have started with. So it's part of the question anyway, they ask you to write this equation. We're going to use the symbol M for our metal. They tell you after the reaction ends up with a +2 charge. So because it ends up with a +2 charge, I know the formula of the chloride salt will be MCl2. Okay, if that's +2, I need 2 chlorines with a -1 charge to cancel it out. So that's going to be my equation. And you can see using that equation that the ratio between my metal and my acid is 1:2. If we know the number of moles of acid that reacted, 0.1228, 0.1228, we can just divide that number by 2 to work out the number of moles of metal that we must have started with, 0.0614. So now I know the number of moles of metal that I must have started with. And if I scroll back up here, you'll see that they also give me the mass of metal that I started with. So we're trying to just identify this metal. If we take the mass of the metal that we started with, we divide it by the moles that we started with, we'll get the formula mass of the metal, and we can use that to identify. So working that out, there's the mass, there's the number of moles, and your formula mass of the metal is 112.4. Once I know the formula mass of the metal, and then I'm going to go to the periodic table and try and find a metal that has an atomic mass of 112. And when I do that, I end up with the answer cadmium. Cadmium must be my metal. So again, it might feel like quite a long calculation, but ultimately you are just doing the same thing. You're going to start with your titration. You're going to remember to scale up to 250, and then you're going to use the information that you were given about the starting acid to work out how much reacted and therefore how much metal must have reacted. Again, even if you get a little bit lost in your calculation, if you just do each step that you do, if you just label clearly what you are doing, you will pick up quite a lot of marks along the way, even if you can't get that final answer. You just have to be clear in your working and make sure everything is properly labelled.